Algebra 1. This is our final exam, guided review 1. So just like we've done with the tests, you can either just do these problems on your own, and then I recommend checking your work against mine, checking your answers against mine, or you can just do the problems as I do them as a way of getting the extra review and instruction. Splash up at the top here what we're doing. This is Algebra 1. And this is Final Exam Guided Review 1. It's a lot to write, but I suppose I'll do it. Final Exam, it's because I care. Man, struggling. Guided Review 1. We're going to do 2 of these. This one is 10 questions. The next one I think will also be right about 10 questions, and that'll cover all the different types of problems that you can run into. So here we go. Number 1. Number 1 is find the slope. Find the slope between the points we have -4, 3 and -2, 1. Okay, so here we go. Slope, we sometimes call it M. It is, one way of putting it is rise over run, which is another way of saying it's our delta y, which is our change in y, over our delta x. Okay, how much we go up, that's our delta y. How much we go side to side, that's our delta x. Which another way of putting that is y2 minus y1 over x2 minus x1. In other words, our second y value minus our first y value over our second x value minus our first x value. And you could do first minus second over first minus second, as long as you do first minus second on top and bottom. Here we have second minus first on top and bottom. So let's go ahead and do it as second minus first. So our second y value is going to be this one. So that's going to be 1 minus 3 over -2 minus -4. Be very careful with negatives. So what do we get here? 1 minus 3 is -2. -2 minus -4, that's the same thing as -2 plus 4. So that gives us -2 over -2 plus 4 is a +2. -2 over +2 is -1. So that's our slope. Sometimes you'll get an integer like that, like negative, slope of -1, a slope of 2, a slope of 5. Sometimes you'll get a fraction, like a slope of 3/4, a slope of -7/5. All right, that's number 1. Number 2, we have find the x-intercept and the y-intercept. Find the x-intercept and the y-intercept. I'll shorten that to y-int of x minus 2y, 2x minus 5y, 2x minus 5y equals 1. Okay, the x-intercept is where the graph crosses the x-axis. The x-intercept is an x value, which means we want to keep x and we want to get rid of y. That's one way of kind of reminding yourself what you do. So I could put here, let's see, x-intercept. For the x-intercept, y equals 0. So we plug 0 in for y to get the x-intercept. So we get 2x minus 5 times 0 equals 1, which means 2x equals 1, which means x equals 1/2. So that is our x-intercept. You could write it just as x equals 1/2, or it might be a little bit more clear if you wrote it as the point 1/2 as a coordinate, 1/2 comma 0. Because that's just a little more clear. Oh, we're talking about a point. It's the point with an x value of 1/2 and a y value of 0. I am in future years going to go more of a recommendation for doing it this way, because I've seen too many students this year and in past years when they get the y-intercept or the x and y-intercepts. Well, I'll show you what students are tempted to do so we can avoid it. The y-intercept is when x equals 0. So we do the same thing. We take our equation, but now we're plugging in 0 for x. So we have 2 times 0 minus 5y equals 1. So that means negative 5y equals 1, which then gives us y is negative 1/5. Or we could write that as the coordinate 0 comma negative 1/5. Okay. So this problem didn't ask you to graph it, but if you're asked to graph this, then we would have our axes. Now I'm going to scale this by fifths just to help make this a little bit better. So 1/5, 2/5, 3/5, 4/5, 5/5. So that's 1. Okay. 1/5, 2/5, 3/5, 4/5, 5/5. That's 1. Negative 1/5, negative 2/5, negative 3/5, negative 4/5, negative 5/5, negative 1/5, negative 2/5, negative 3/5, negative 4/5, negative 5/5. That's negative 1. That's negative 1. So what some students want to do is when they just get, oh, x equals 1/2, y equals negative 1/5, they go to 1/2, negative 1/5, and they put a dot there. But that dot is not on the axis. That is not an intercept. An intercept is going to be a dot on the axis. If it's an x-intercept, it's a dot on the x-axis. If it's a y-intercept, it's a dot on the y-axis. So that's why this coordinate way is a little bit better, because it makes it a little bit more clear. Oh, we have two different points here. We have the point 1/2 comma 0. So that's going to be the point. So if I do this one in yellow now, 1/2 comma 0, that's going to be there. And we have the point 0 comma negative 1/5. 0 comma negative 1/5 is going to be there. And then you connect them to draw your line. Ooh, that's going to be way too curved. Connect them to draw our line. About like that. All right, so that's the intercepts and how to use the intercept for graphing a line. Moving on, do I have space to do? Sure, number 3. We can cram it down here at the bottom. Number 3 is graph y equals 3/4 x minus 2. Well, here's what we know. We know our slope. Well, I guess before I say that, this is slope-intercept form. Slope-intercept form, which is y equals mx plus b. So what do we know? We know our slope. Our slope is 3/4. So wherever we start with this graph, whatever point on the line we start with, we're going to go up 3, right 4 to have a rise of 3 and a run of 4. And then our y-intercept, that's what intercept we have. Our y-intercept is negative 2. So I'm going to draw my axes. X-axis, y-axis, 1, 2, 1, 2, 1, 2, 1, 2. I'm going to start at this y-intercept of -2. Then from there, I'm going to go up 3 to the right 4. So I'm going to go up 1, 2, 3, and then to the right 1, 2, 3, 4. So it's going to be up 3, right 4 to give me my 3 over 4, my rise over run. Now I have those 2 points. I can connect them to graph the line. And there we go. Okay, that's number 3. Number 4. We have write an equation in slope-intercept form and then state the slope in the y-intercept. So this is almost the same. Sorry about that sound. I don't know if you heard that or not. It's, okay. Number 4. So we have an equation and we're asked to write it in slope-intercept form. And then state the slope and the y-intercept. So part B is just like number 3 as far as stating the slope and the y-intercept, but we need to rearrange the equation first. So here's what we have. We have write x minus 2y equals -6 in slope intercept form. And let's go and do that part first before we write part B. So I just need to get this as y equals. In other words, I need to solve for y. So I am first going to subtract x from both sides. So that will give me -2y equals -x minus 6. I put the x chunk first because that's how slope-intercept does it. Then I need to divide everything by a -2. Divide by a -2, divide by a -2. So that will give me y equals -1 over -2 is a positive 1/2 x. And then -6 over -2 is a plus 3. So that is my equation slope-intercept form. And then part B is to state the slope and y-intercept. State the slope and y-int. All right, well, I had this information built into the form of the equation that I'm working with. So the slope is 1/2. That's that answer. And the y-int, y-intercept, is 3. Okay, that is number 4. Number 5. Find the slopes of, and then we're given 2 equations, and determine if they are parallel, perpendicular, or neither. So find the slopes of 3x plus 5y equals 10. And 5x minus 3y equals -6. So let's start with that. Let's find these slopes. So the way I prefer to find slope is, again, to rearrange it into slope-intercept form, and then just pull the slope from the x coefficient. So let's do this one. So then this one becomes 5y equals -3x, because I threw it to the other side, plus 10. So now we need to divide everything by 5, so I get y equals -3/5 x plus 2. So then this one, the slope is -3/5. And then this one, I'll get -3y equals -5x, because I threw the x chunk to the other side, minus 6. Now we need to divide everything by a -3. So that gives me y equals positive, because -5 over -3 is a positive 5/3 x. And then negative 6 over negative 3 gives me a plus 2. So this one, the slope is 5/3. That's that slope, and that is that slope. That's that answer. Now let's do, so that was part A. Part B. Determine if parallel, perpendicular, or neither. All right, well, parallel, they need to have the same slope to be parallel. So the same slope would be like a slope of -2 and -2, or a slope of 4/3 and 4/3. Okay? Perpendicular, what we say is the slopes are negative. In other words, one is positive and one is negative, reciprocals. So inverses of each other as far as like flipping it upside down. So 2 and -1/2. Well, reciprocals would be like 2 and 1/2, or 3/4 and 4/3, or 7/8 and 8/7. Then negative means one needs to be positive and the other is negative. Another way of telling negative reciprocals is if you multiply the two slopes, you will get -1. Um, so let's see, or m1, slope 1 times m2 equals -1. That's another way of checking. Which, let's see, that looks like what we have going on. If I do -3/5, let me do this in blue. -3/5 times a positive 5/3. Well, here I have a 3/3, and here I have a 5/5. All those cancel. Things cancel mean they're 1. And so what am I left with? I am left with -1, so these are perpendicular. And that is number 5. Number 6. Solve this absolute value problem. Absolute value of x plus 4 equals 2. All right, so this is our absolute value equations when we solve them. That's when we have case 1 and case 2. Oops, let me do blue because that's what I'm doing my work in. Case 1. My high school, we actually had to do homework in black and in-class work in blue. It was a way for the school to make sure that you weren't trying to do homework in class, because you had to turn your stuff that you did outside of class, you had to turn that in with a black pen with black ink, and the stuff that you did in class you had to do with the blue ink. So if the teacher saw that you were writing in class with a black pen, they could be like, whoa, hey, you're apparently trying to do homework in class. Okay, case 1. What we do is we just rewrite the equation, but without the absolute value. Rewrite without the abs val. Without the absolute value. So that just gives us x plus 4 equals 2. So we solve by subtracting 4 from both sides, so we get x equals -2. So that's one solution. And then case 2, what we do is abs val. Let's see. Instead of absolute value, we rewrite it as negative parentheses. So we're going to do this as negative x plus 4 equals 2. So then negative x minus 4 equals 2. So I need to add 4 to both sides. So negative x equals 6. So then x equals -6. Yes, there is a quicker, more straightforward way of doing it, but if you get too ingrained in doing it the quicker, more straightforward way, you will almost certainly end up missing absolute value inequality problems because you will forget to reverse the sign and you won't really understand what's going on as much. So there you go. This is another way of saying these are our solutions here are the two numbers that are 2 units away from the number -4 because this is a minus whatever the value is. So a minus -4 would give us a +4. That's what's going on with our solutions here. So like if we graph them on a number line, what this problem is saying is our target is -4, and we want to know what numbers are 2 units away from that. 2 units away, 2 units away. What numbers do we get? We get -2 and -6. Our answers there. Okay, that was number 6. Number 7 is use substitution to solve. Use substitution to solve. And we got two equations here. 5x minus y equals -1. 5x minus y equals -1. And 4x plus y equals 10. 4x plus y equals 10. So substitution is where we need to get one of the equations rearranged as x equals whatever or as y equals whatever. And then what if we rearrange to be as y equals whatever, then what the whatever is, we plug in for y in the other equation. So you can do it solving for either x or y, but I usually like to look and see, well, what's going to be the easiest for me to rearrange in order to get as x equals y equals. So I see that with this one, I have a y, a 1y, instead of like a 5x, because I'm like, if I solve for x here, I'm going to have to end up dividing everything by 5, and then I have fractions to deal with. And if I can avoid fractions, that'd be great. So I like the look of this y more, but that's a negative y. So I'm also going to have to reverse the sign of everything, which isn't that big of a deal. But what I see is I see this one, I have a positive 1y. I can solve for y in one step, and that's the most straightforward. So I'm going to rearrange this as y equals -4x plus 10. Okay, so what y equals in this equation, so when we solve equations, we're finding the point where their x value and y value is the same. The point where the two lines intersect each other. And so because their x value and y value is the same, I can take what y equals in one equation and plug it in for y in the other equation. So let's take this equation and rewrite it, but with the new y value plugged in. So I'm going to have 5x minus, now what am I plugging in for y? -4x plus 10 equals -1. Okay, that's my substitution. I took what y equals. In this case, we're using what y equals. Again, you can use what x equals. In this case, I took what y equals in one equation and I plugged it in for y in the other equation. I substituted it in. Now, we have an equation with one variable, x, and numbers, and I can solve that. So let's see what we get. This gives us 5x minus a -4x gives us plus 4x, and then minus 10. Minus 10 equals -1. So let's combine these so we get 9x equals, well, -1 plus 10 is going to give us 9. So therefore, x equals 1. Okay, so I know what x equals. Now I can plug that in. I can plug that value into one of my original equations. So I oftentimes like to take what my value is here, and so let's grab this one now. So this is what we did first. This is what we're doing second, and then this is what we're doing third. I'm going to say, well, y equals, because I already have one that is saying solve for y, and that's what I want to do now. I want to solve for y with the information that I now have about what x is. So I'm going to say y equals -4 times 1 plus 10. So that gives me y equals -4 plus 10. What is that? That is y equals 6. And then how do I write my answer? I write my answer as a coordinate, as the point 1, comma 6. Now, if you were asked to check your answer, you would plug 1 comma 6 into the original equations and see if it checks out, which we can kind of mentally do that. 5 times 1 is 5. Minus 6, 5 minus 6 is -1. Cool. How about this one? 4 times 1 is 4, plus 6, 4 plus 6 is 10. Nice, it checks out. Okay, that's number 7. Number 8. We're solving again, but this time we're going to use elimination. So use elimination to solve. And what are we solving? We're solving 4x minus 2y equals 0. And 4x plus y, no, wrong one. Number 8, 10x plus 3y equals 8. 10x plus 3y equals 8. Okay, we're going to have to do a little bit of work here because elimination, we need either our x coefficients to match or our y coefficients to match. And right now, neither of them is matching. So I'm gonna have to do some multiplying. So let's take this one. And I'm looking at my numbers. My x's I have a 10 and a 4, 4 and a 10. My y's I have a 2 and a 3. And 1 is negative and 1 is positive. 2 and 3 are smaller numbers. They're going to be a little bit nicer to deal with. It would be nice if, like, instead of a plus 3y, if this was like a plus 6y. Because then I could just multiply this first equation by 3, and my negative 2y would become a negative 6y, which now would match the 6y that I have here, and I'd be set up to eliminate y's. But yeah, but we don't have either of the variables with coefficients, whereas one x coefficient is an even multiple of one of the x coefficients. So neither do any of our coefficients match each other, but also we don't have like x coefficient where one of them is a multiple of the other, or a y coefficient where one of them is a multiple of the other. So that's why we have to multiply both equations by something. But what I can do is I can multiply this first equation by 3 and this second equation by 2. And so if I multiply the first equation by the second equation's y coefficient, and the second equation by the first equation's y coefficient, then they'll match. So let's take this first one and let's do times 3. That's going to give me 4 times 3 is 12. 12x minus 2 times 3 is 6, minus 6y equals 0 times 3, 0. And then let's take this one and multiply it by 2. So 10 times 2 is 20x. 3 times 2 is plus 6y equals 8 times 2 is 16. Okay. I'm actually going to do this in yellow and do my other work in blue. So that'd be 12x minus 6y equals 0. Now I look at so I'm like, all right, what variable did I set myself up to eliminate? I set myself up to eliminate the y's, and I asked myself, would I subtract or add to eliminate the y's? Well, if I did -6 minus 6, I'm going to get -12y. So I need to add these. So we get 12 plus 20 is 32x. -6y plus 6y is nothing. And then 0 plus 16 is 16. So now we can divide both sides by 32. And that gives me x equals 16 over 32, which is 1/2. Now I can pick either one of my original equations and substitute 1/2 in for x, and I can go from there. So let's see what we get. Um, I'm going to go with the first equation. It looks a little bit nicer to deal with. So let's do 4 times 1/2, because that's what x is, minus 2y equals 0. So this is 2 minus 2y equals 0. So if I subtract 2 from both sides, I get negative 2y equals negative 2. Divide both sides by negative 2, and I get y equals 1. So my solution again is a coordinate x value, 1/2, comma, y value, 1. And we could take 1/2 for x and 1 for y and plug them in for x and y in either one of the equations, and it would check out. That's number 8. Let's see what number 9 is. Oh, number 9, we are multiplying a monomial by a polynomial. Find the product. And what do we have? We have 3xy times 7x to the 4th y squared plus x cubed y minus 2y. Okay, so we just take this chunk by chunk. So the numbers multiply 3 times 7, that's 21. X times an x to the 4th gives me an x to the 5th. Y times a y squared gives me a y cubed. And then plus 3 times 1, so still 3. X times x cubed is x to the 4th. Y times y is y squared. And then minus 3 times 2 is 6. I don't know what happened with that 6. Let me make that a little bit better. Whoa, I did it again. I think it's something with how my... Okay, that's better. X, we just have the 1x. Y times y, y squared. And I can only combine these, if they exactly match each other. I can only combine terms if they exactly match each other in what letters they have and to what powers. So this chunk is an x to the 5th y cubed chunk. It can only combine with another x to the 5th y cubed chunk. And I don't have any other x to the 5th y cubed chunks. This chunk, this term, is an x to the 4th y squared term. It can only combine with another term that is x to the 4th y squared, and I don't have any other x to the 4th y squared terms, so there's no simplifying that we can do here. And finally, number 10. Number 10 is find the sum or difference. The sum or difference and simplify. Okay, what do we have? We have 3x squared minus 7 plus 4x plus 7 minus x squared plus 5x minus 8. Okay, one way of doing this is to get rid of the parentheses and distribute any negatives that you need to. So maybe let's do that first. So we have this positive 3x squared, right, because this is an understood positive there, minus 7, and we have plus 4x plus positive 7 minus x squared minus 5x, because this negative here distributes to this whole chunk. So be careful. This is minus this whole chunk. And we have minus a negative 8, which becomes plus 8. Okay. So let's see. What do we have that are x squared terms? We have a 3x squared minus x squared. That gives me a 2x squared. And then next I would put the terms that are just x, that have just an x and x to the first, just to keep things in standard order. So I used this term and that term. It could be good to keep track of what you've used. And then, so we're doing the x's first. So I have a plus 4x minus 5x. 4 minus 5 is negative 1. So that gives me a minus x, technically minus 1x, but we just write it as minus x. So I use that and that. And I have negative 7 plus 7, that's 0. Plus 8 gives me plus 8. And that is my final answer. And that is the first half of what to review for the final exam. So hope that's all making sense. You're feeling pretty good about stuff that we learned early in the year, especially because a decent amount of this we've built on. So it's like at one point in the year, it was brand new and it was the new hard thing that you were learning. But then we've used it again and again and again throughout the year. So some of this hopefully is seeming a lot easier than it did earlier in the year. All right, I will see you next time.